Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing areas and volumes. We shall be dealing with advanced problems. So the first problem says, the diagram shows the surface of a garden pond made from a rectangle and two semicircles. The rectangle measures 3 by 1.2. Calculate the area of the surface. So first of all, we need to calculate the area of this shape. And the shape in terms of area can be divided into three parts: a semicircle and another semicircle and a rectangle. So let's get the area of each shape. So the area of a rectangle is equal to length multiplied by width. And this is equal to 3 times 1.2, which is 3.6. This would be the area of the rectangle. Now we want to get the area of the first semicircle. Of course, we should know that the semicircle has a radius, and we need to get the radius of this semicircle, which is basically the green line right there. So this green line is half of the entire diameter, and the entire diameter is 1.2. So since the diameter is 1.2, we can say that the radius is 0.6, which is 1.2 divided by 2. So this number here divided by 2 gives us the radius. Now we want to get the area of the semicircle. We should know that the area of a circle is equal to pi r squared. So the area of a semicircle would be half multiplied by pi r squared. We already know the r, which is 0.6. So this is equal to half times pi times 0.6 all squared. And we find this on the calculator. So 0.5 times pi times 0.6 squared. This gives us 9/50 multiplied by pi. And we know that there are two semicircles, one on the right, one on the left. So we got the area of this shape so far. We want to get the area of the other shape. Of course, they are exactly the same as each other. They are congruent to each other. So therefore, the total area would be 2 times 9/50 pi. And this is equal to 18/50 pi. Finally, we add the area of the two semicircles to the area of the rectangle. So the total area would be 3.6, which is this number here, plus 18/50 multiplied by pi. We use the calculator to find this. And the final answer is going to be 4.73. So the area is equal to 4.73. Let's check the marking scheme to make sure that we are okay. 4.73 is the correct answer for question A. In B, they are telling us that the pond is a prism and the water in the pond has a depth of 20. Calculate the number of liters of water in the pond. So number of liters is a unit to measure volume. So this is the same as saying calculate the volume. What is the volume of any prism? So the volume of any prism is equal to base area multiplied by height. Be careful of the units in this question because the height here is 20 centimeters, whereas the other dimensions are given in meters. So we can say that the height is equal to 20 divided by 100, and this is equal to 0.2 meters. And the base area, we already got it. Let's just remember it from the marking scheme. It's 4.73. We don't need to calculate it again, of course. So this is 4.73 multiplied by 0.2. And 4.73 times 0.2 gives us 0.946. So the volume in meter cubed is 0.946. but they want the volume in liters because they want the number of liters of water. So you should know that 1 meter cubed is bigger than 1 liter, and 1 liter is bigger than 1 centimeter cubed. So 1 liter is exactly in the middle between 1 meter cubed and 1 centimeter cubed. And the link between them is to multiply by 1000. So if you multiply by 1000 here, you get liters, and if you multiply by 1000 again, you get centimeters cubed. So in our case, we have 0.946. We multiply by 1000, so we get 946 liters. This would be the volume of the prism. Let's check the marking scheme. So in B, 946 is the correct answer. So just to be able to solve C, let's write down what we figured out so far. So the area is equal to 4.73, and the volume is equal to 946 liters. In question C, we are told, after a rainfall, the number of liters of water in the pond is 1007. Calculate the increase in the depth of water in the pond. Give your answers in centimeters. So now they want us to calculate the new volume because of the additional water due to the rain, and then use that in order to get the volume. Remember, in order to get the depth, excuse me. Remember that the area is given in meters squared and the volume is given in liters. How do I know that the area is in meters squared? Because in question A, we were using quantities that all had the unit of meters. Now, the new volume is equal to what? The new volume is equal to 1007. So in order to get the additional volume or the increase in volume, because they want the increase in depth. So just to get the increase in volume, all we have to do is get the difference between them. So 1007 minus 946. So increase in volume is 1007 minus 946. And this gives us 61 liters. They want the answer in centimeters. So let's get the same amount, the same volume, but in centimeter cube. So the increase in volume here is going to be 61. And we said we multiply by 1000 to get centimeter cube. So we have 61,000 centimeters cubed. This is the increase in volume. In order to get the height in centimeters, we need the area to be in centimeters as well. So we need the area here to multiply. So from 1 meter to go to 1 centimeter, you multiply by 100. From 1 meter squared to go to 1 centimeter squared, you multiply by 100 squared. So we multiply here by 10,000 in order to get the area. So 4.73 times 10,000 would be 47300. This would be the area in centimeters squared. And we know that the volume is equal to base area multiplied by height. The volume is 61,000. The base area is 47,300. And we want to find the height. So the height is equal to 61,000 divided 47,300. And we use the calculator. The answer is 1.29. So 1.29 centimeters. Let's check the marking scheme. 1.28 or 1.29 are both correct, depending on your approximations. So we are okay with 1.29 for C. The volume of a solid metal sphere is 24,430 centimeters cubed. Calculate the radius of the sphere, and you're given the formula for the volume, which is 4/3 pi r cubed. So V equals 4/3 pi r cubed, 24,430 equals 4/3 pi r cubed. We take the fraction to the other side. So we flip the fraction, we get 3/4 times 24,430, excuse me. This is equal to pi r cubed. And then we divide by pi. And we take a cubic root in order to remove the pi and the power 3. So r is equal to cubic root of this expression. So let's just use the calculator. We type in cubic root and then we use the fraction button. And in the numerator, we put 3/4 or just 0.75. You can just open brackets and write 3 divided by 4 and then close the brackets in the numerator. And then multiply by 24,430. And in the denominator, you have pi. And the calculator immediately finds r. R is 18.000 something, so it's just 18 centimeters. So let's check the marking scheme. 18.0 is correct for AI. So let's move on to double I. R equals 18. The metal sphere is placed in an empty tank. The tank is a cylinder with radius 50 standing on its circular base. Water is poured into the tank to a depth of 60. Calculate the number of liters of water needed. So first of all, let's calculate the volume of the cylinder. So the cylinder is an empty cylinder standing on its circular base, and the R is 50, and the H is 60. So the required amount of course, the volume of the water here is going to be the volume of this small cylinder within the cylinder up to the height, which is filled with water, which is base area multiplied by height. Base area, of course, would be pi r squared. And this is multiplied by the height. So pi times 50 squared times 60. This would be the volume. Let's use the calculator to figure this out. So pi times 50 squared times 60. This gives us 471,239 approximately. So this is the volume of water in the cylinder. However, this is not the actual volume of water or the amount of liters needed, because we are already placing the metal cylinder or the metal sphere, excuse me, in the tank. So this volume is two things together, the water and the metal sphere. So we need to subtract the volume of the metal sphere from the answer in order to get only the amount of water needed. So the answer would simply be 471,239 minus 24430. This would be equal to the volume of water. So the volume of water is going to equal, and then we use the calculator, 471,239 minus 24430. We get 446,809. Centimeters cubed. Of course, we said before that to go from centimeter cubed to liter, we want to remember that we have 1 meter cubed, 1 centimeter cubed, and 1 liter in the middle. And to go from one to the other, we just multiply by 1000. So in this case, in this problem, we have the answer in centimeter cubed, but they want the number of liters. So we have to divide by 1000. Hence, the final answer would be 446.8 liters. I just divided by 1000, so you move the decimal up to here. 446.8 liters, or even 447 liters. And this is the correct answer in AII. So we have the correct answer here, and we can move on to the next problem. The diagram shows a hemispherical ball of radius 5.6 and a cylindrical tin of height 10. Show that the volume of the ball is 368 centimeters cubed, correct to the nearest centimeter cubed. So this is a ball, which is basically half of a ball, half of a circular ball. So if you have a ball or a sphere, this would be half of this sphere. The volume of a sphere is 4 over 3 pi r cubed. So the volume of a hemisphere would be half times the same equation, half multiplied by 4 over 3 pi r cubed. And the radius here is 5.6. So we just simply substitute into the equation. Half multiplied by 4 over 3 pi multiplied by 5.6 cubed. And we use the calculator. So 0.5 times open bracket 4 divided by 3 close bracket multiplied by pi multiplied by 5.6 to the power of 3. And you get 367.8. You have to write this number down with the decimal so that you show that the volume you obtained is not 368 exactly. You have a different answer because they already gave you the 368. So you can't just write it down. They're looking for an approximated value. So they're looking to see this value. And then you can say approximately equal to 368 centimeters cubed. For double I, they say the tin is completely full of soup. When all the soup is poured into the empty bowl, 80% of the volume of the bowl is filled. Calculate the radius of the tin. So this is a nice problem showing an example where you go from one container to the other and they don't exactly match. One of them is 80% of the other. So let's just take it one part at a time. We are told that 80% of the volume of the bowl is filled. And we already know that the volume of the bowl is 368. So what we need to do here is first calculate 80% of 368. Using your calculator, you get a volume of 294.4. This is the volume of soup that filled the bowl. And we are told that the tin is completely full of soup. So the volume of the soup is the same as the volume of the tin. So we can deduce that the volume of the tin is also 294.4. Now the tin is a cylinder. How can we find the volume of the tin? It's base area multiplied by height. So base area multiplied by height would be pi r squared multiplied by height. And this has to equal 294.4. We are required to find the r, the radius. And everything here is in centimeters, so there is no need to convert from any unit to another. We will just work with centimeters as per the given information. So all we have to do now is just say pi multiplied by r squared, which we don't know, multiplied by 10, which is the height. This is equal to 294.4. So we need to isolate the r. So r equals, first of all, we take the pi and the 10 to the denominator. So 294.4 divided by 10 pi. And then to get rid of the power 2, we take a square root like this. So square root and then fraction, and then 294.4 in the numerator, and then 10 times pi in the denominator. You get 3.06 for R. So therefore, the answer to AII is equal to 3.06. Never mind B, it's not relevant to this video. So 3.06 is the correct answer here. In this final question, the diagram shows a sector of a circle with center O, radius 8, and sector angle 165. Calculate the total perimeter of the sector. So in order to get the perimeter, we need to realize that this side here is part of the perimeter, this side here is part of the perimeter, and this length of arc here is also part of the perimeter. So the perimeter is equal to R plus L. How do we get L? L is the length of an arc, which is part of a circle. So we write down the perimeter of a circle. So this is L here, and L equals perimeter of a circle multiplied by a certain fraction. It's not a complete circle. It's only part of a circle. So how do we get this part? Using the angle here. So the fraction will be 165 divided by 360, because 360 is the angle for the entire circle. And since we want only a part of the circle, we're going to take the angle that they gave us and put it over 360. So the R is equal to 8. And therefore, we can use the calculator. 2 times pi multiplied by 8 multiplied by 165 divided by 360. This gives us 23.04. So now that we know L, we can just plug in the values. So R is 8, the other R is 8 as well, and the L is 23.04. So the final answer would be 39.04, or maybe even just 39 to 3 significant figures. Let's check the marking scheme. In question A, the total perimeter is, in fact, 39. The surface area of a sphere is the same as the area of the sector. Calculate the radius of the sphere. So what is the area of a sector? Again, we said that the sector is part of a circle. So the area would be the area of a circle, which is pi r squared, multiplied by the fraction of the circle represented by the sector, which would be 165 divided by 360. So instead of R, we can put 8, so it would be 8 power 2, and we can just use the calculator to get the area of the sector. So pi times 8 squared times 165 divided 360. This would give us 92.15. This would be the area of the sector. We want the radius of a sphere which has the same surface area as the area of the sector. So the area of the sphere, which is given as 4 pi r squared, is equivalent to the area of the sector, which is 92.15. Now we want to get R like we did before. We isolate the R. So R is going to be, first of all, we take the 4 and the pi to the other side in the denominator, and then we get rid of the power by taking a square root. So square root and then fraction, and then 92.15 in the numerator and 4 times pi in the denominator. You get 2.71 for the radius. Let's check the marking scheme. So the answer to B is 2.71, and we are going fine so far. This next part is very important, and you should be familiar with this particular type of problem. You can always turn a sector into a cone by simply wrapping it up. And there are a lot of cones in Egypt, at least. There are a lot of people who cut out a sector and then turn it into a cone to fill it with some snacks that are common in Egyptian streets, like peanuts and so on, and corn and so on. So anyway, this ortos, it's called in Egypt, is what we call a cone, and it is made from a sector. And you should know how to go from a sector to a cone. So how do we do that? First of all, this L here, which we already got, by the way, is the same as this circle here. So this is what you need to understand, because this L or this arc length here, which we called L previously, if you wrap it up around itself, you get the circular base of the cone. So one very important equation when you're going from a sector to a cone is to say L equals 2 pi r. So what was the value of L? Let's calculate it again very quickly as a reminder. To get L, when we got the parameter, we said that L is equal to 2 pi r times 165 over 360. And r here is the r of the sector, which is 8. So let's calculate it again. So 2 times pi times 8 times 165 divided 360. This gives us 23.04. So now we know that for the cone, this entire circle has a length of 23.04. And this can help us to get this radius here, which is the radius of the base of the cone. And it's not the same as the radius of the sector, of course. It's not going to be 8. We need to calculate it. So how do we calculate it? Simply by understanding that this is the parameter of the circle. And this r here is the r that we want. So all we have to do is just say 2 pi r equals 23.04. And we can take the 2 and the pi to the other side. So the r of the circle would be 23.04 divided by, or better to write a fraction and write 23.04 in the numerator and write 2 times pi in the denominator. You get 3.67. And this is what they're looking for in question I. Let's check the marking scheme to make sure we are on the right track. 3.67 is the correct answer for CI. In double I, we are required to calculate the volume of the cone, and they gave us the formula. So the volume of the cone is 1 over 3 pi r squared h. Another issue or another fact that you need to know about cones is that there are 3 values that are related together by the Pythagorean theorem. These 3 values shaded in green, which are h and r and l here. This l is formed from the radius of the sector. So the other r, the r that was in the sector, is the same as the L of the cone. So watch out, because this can get a bit confusing. If we have a sector, the arc length of the sector is equal to perimeter of circle in cone. And the radius of the sector is equal to the slant height, which we call L of the cone. So we're going to take this 8 and simply shift it over here. So the slant height of the cone is going to equal 8, same as the radius of the sector. Now that we have the 8 and the r, we can get the h using the Pythagorean theorem. You can say h squared equals r squared. Excuse me, you can say 8 squared. I apologize for this mistake. 8 squared equals r squared plus h squared. Regular Pythagorean theorem, this is a right angle triangle here. So the hypotenuse squared, which is the 8, is equal to the other 2 sides squared added to each other. So we use this equation here and we plug in the radius as 3.67. And we want to get h squared, or we want to get h. So let's just calculate each value. We have 64 here. And then 3.67 squared is 13.4689. plus h squared. So by subtraction, we can subtract 64 minus 13.4689. We get that h squared equals 50.5 or 50.53. And then the square root of the answer is 7.11. So this is the value of h. Why do we need the value of h? Because it's part of the formula that we need to use here. So the volume is 1 over 3 pi, and then for r squared, we use 3.67 squared, and then the h we found to be 7.11, and we can get the volume by the calculator. So 1 over 3 multiplied by pi multiplied by 3.67 squared multiplied by 7.11, you get 100.28, or just simply 100 centimeters cubed. Let's check the marking scheme as well. So for double I, the answer is 100, so this is correct. This brings us to the end of our video. I hope this has been beneficial. Thank you for watching.